With this problem, we have f is the function given by f of x is 6e to the negative x over 3 for all x. And we want to find the first four non-zero terms and the general term for the Taylor series for f about x equals 0. So we'll start from e to the x. And hopefully you recall that e to the x is 1 plus x squared over 2 factorial, has all of the terms and they're all positive, and we have factorials in the denominator. 3 factorial, etc. Alright, so if we wanted then e to the negative x over 3, then we're going to replace each x with negative x over 3. So 1 plus negative x over 3 plus negative x over 3 squared over 2 factorial plus negative x over 3 cubed over 3 factorial. And that is going to give us 1 minus x over 3, then again minus, sorry, no, that's plus because it's squared, x squared over 3 squared, so we'll have x squared over 3 squared times 2 factorial. Then this one will be minus. We'll get x to the third over 3 to the third times 3 factorial. And it will go on like that. Then, if we want 6 e to the negative x over 3, that would give us 6 minus 6x over 3 plus 6x squared over 3 squared times 2 factorial minus 6 times x cubed over 3 cubed times 3 factorial. So then I'll label n, and let's see what we have here. We want to relate each term to n. Obviously in the numerator we're going to have a negative, and it starts off a negative 1, and since the first term is positive, that must be to the 0 power. So negative 1 to the n, then times 6x, and it appears that that is simply to the nth power as well, divided by, we have 3 to the 0, 3 to the 1, 3 to the 2, 3 to the 3, that's 3 to the nth power, and then n factorial as well in the denominator. And I think we're all set for part A then. For part B, if g is the integral of f, then we want to find the first four non-zero terms and the general term for the Taylor series of g. So we'll do this in green. If g of x then is the integral from 0 to x of f of t dt, then we just need the term by term integral, so we'd get 6x, then minus 6x squared over 2 times 3, 6x squared over 2 times 3 to the first, then plus 6, sorry about that, 6x to the third over 3 times 3 squared times 2 factorial, and then minus 6x to the fourth over 4 times 3 to the third times 3 factorial. Now, and we are asked for the general term here, so let's see if we can straighten this up a little bit. And actually then we just need to take the integral of the nth term, and that integral would be still -1 to the nth power, and still 6 x to the n plus 1 now, divided by, in addition to what was there already, n plus 1 times 3 to the n times n factorial. And so if we wanted to double check that, 0 term, first term, second term, third term, in the numerator we still have our alternating factor there, then 6x to the 1 more than n, and that's correct. In the denominator we have let's see, n plus 1, good, it is n plus 1, then times 3 to the n and n factorial, and that should do it for parts A and for part B of this problem.